As we're talking about linear equations or lines, one key aspect of those lines is the slope of the line. So in this video, we're going to be talking about how to find the slope of a line given a graph or given 2 points, two ordered pairs. Okay, so slope, basically, a quick definition of slope, it's the measure of the steepness. So say we have a line with a really large slope, like 25. That's going to be a super steep line that almost looks up and down. We also might have a really small slope, like 1/10, and that's going to be a line that's really not very steep. It's pretty flat, and it grows very slowly. So when we talk about slope, we really have 4 kinds of slope, and I'm going to draw them over here to the side. If we have a line that goes up to the right, like this one, that's a positive slope. If we have a line that goes down to the right, like this one, that's a negative slope. Those are the 2 most common. We might also see a horizontal line that has a slope of 0. The last one, that's a kind of funky one. If we see a vertical line up and down, we can either say that has no slope, and notice no slope is not the same as 0 slope, or we can say that the slope is undefined. And we'll show why that is in the next part when we talk about the slope. All right, so when we are finding slope on these 4 graphs, we're finding the slope of the line given the graph. When we do that, our slope, we usually use m to represent our slope. That's the variable we see. We use rise over run. It's a ratio or a fraction comparing our rise, which is our horizontal change, to our run, which is our, our rise, which is our vertical change, to our run, which is our horizontal change. Okay, so you can see that shown here in example 123 and 124. And a lot of times we'll draw, I call it a slope triangle to help us see our rise and run. I always start with our left point and move vertically first. So in this case, we move down, and we move down 4, so our rise would be -4. And then we run, we move horizontally. We move to the right 6, so that means our run is +6. So when we write that as a fraction. Our slope is the rise, which is -4, the run, which is 6, and then we see if that fraction can be simplified, which this one can, and it simplifies to be a -2/3. And just by looking at it, we know that our slope was going to be negative. So if you ever, if we find our slope and we get +2/3 and it doesn't match our graph, we know that one of those is going to be incorrect. Okay, let's look at example 124. Again, I always start with my left point. If we always start with our left point, we know that if we move up, my slope is positive. If we move down, my slope is negative. That's what's nice about consistently starting with your left point. So here we move up, we are rising 6, so our rise is +6. And our run, we move horizontally 3 spaces, so our run is 3. So when we write our slope as a fraction, we have our rise, which is 6, our run, which is 3. That can simplify to be 2/1, or just 2. So the slope of that line is a +2. Okay, notice these funky ones. Let's talk about why this is a slope of 0. If I start with my left point, we move our vertical change first. Well, we don't move any, so our rise is going to be 0. Our run is going to be 1, 2, 3. 0 divided by 3 gives me 0. This one right here is kind of the opposite. If I start with this bottom point, I rise, let's see, 1, 2, 3, 4, 5. But I run 0, and if we try to do this in your calculator, 5 divided by 0, it's probably going to give you an error message. That's because we can't divide by 0. So if we ever see division by 0, our answer is going to be undefined, or we can say we have no slope. Either one of those is okay. But sometimes we're not going to be given a graph. Sometimes we're just going to be given 2 ordered pairs, and we're asked to find the slope between those. We obviously could draw a graph our points, count our rise and run, but a quicker and easier way to do this is using our slope formula. So we've kind of broken it down right here. Our slope, which we use m to represent that, we already talked about is our rise over run. We said our rise is the change in y, that's our vertical change. The run is the change in x, that's our horizontal change. And another way to say change in y divided by change in x is our y subtracted by our y, we're going to call that y2 minus y1, divided by our x subtracted by our x, x2 minus x1. So if we're given two ordered pairs, we can use this formula right here to help us find our slope. So I'm going to go ahead and label my points, x1, y1, x2, y2. And I'm going to go ahead and kind of draw like the backbone or the skeleton or the outline of this. I'm going to go ahead and draw my big fraction bar, subtraction on top, subtraction on bottom. And then all I'm going to do is replace the values that we have from our points into our slope formula. So I've got y2 minus y1, negative 9 minus 3, x2 minus x1, 2 minus negative 4. And notice here, if you ever see this minus a negative, we know that minus a negative is going to turn into plus. So now we just do this math and simplify. Negative 9 minus 3 is negative 12. 2 plus 4 is 6. If we simplify that, we get negative 2 over 1, or just negative 2. So the slope of that line is going to be negative 2. Okay, same thing on example 127. I'm going to start out labeling my points x1, y1, x2, y2, and we're going to use our slope formula. We're going to have y2 minus y1, negative 1 minus 6, x2 minus x1, 2 minus 4. If we simplify here, we're going to have negative 7 on top, 2 minus 4 is negative 2 on bottom. Negative 7 divided by 2, we know a negative divided by a negative is a positive. So this is going to simplify to be positive 7 over 2. All right, a few more where we're given ordered pairs and we're trying to find the slope. Let's look at example 128. Again, let's label them x1, y1, x2, y2. And I've got that my slope is y2 minus y1, negative 5 minus negative 1, over x2 minus x1, negative 4 minus negative 4. And again, anytime you see that minus and negative, we can change it into plus. Negative 5 minus 1 gives me negative 4. Negative 4 plus 4 gives me 0. Kind of like we saw earlier, if we have 0 on the bottom, that tells me that this is going to be undefined. We can't divide by 0. Another way to say that is to say that this has no slope. All right, on example 129, we've got the point 3, 1, that's x1, y1. We've got the point negative 2, 1, x2, y2. If we set up our formula, we have y2 minus y1 over x2 minus x1. 1 minus 1 gives me 0. Negative 2 minus 3 gives me negative 5. Well, 0 divided by anything is going to give me 0. So again, let's keep straight which lines are which. If I have an undefined slope or no slope, that's a vertical line. If I have a 0 slope, that's going to be a flat horizontal line. All right, and then a few more examples where we're using the concept of slope to help us solve. So example 130, they give us two ordered pairs, but notice we're missing one of the coordinates. We do not know what this y coordinate is right here. But they do tell us that our slope, or our m, is negative 3. Okay, so just so we don't forget it, I'm going to write my slope formula right here. y2 minus y1 over x2 minus x1. So we're going to use these 2 points and the given slope to help us set up our problem. I'm going to label this as x1, y1, x2, y2. Okay, so if we kind of replace what we know in this equation right here, we know our slope, or we know our m is negative 3. So I have negative 3 equals, now let's replace our ordered pair values for the right side of this equation. We have y2 minus y1. That's our unknown, so I'm just going to put minus y over x2 minus x1. Okay, let's simplify just a little bit. I'm just going to simplify that right side. Top, I've still got negative 1 minus y. On bottom, 5 minus 2 is 3. All right, if I want to get rid of this division by 3, I'm going to multiply both sides by 3. Division and multiplication cancel. And I'm going to move up here. I'm left with negative 9 on my left side equals negative 1 minus y. If we keep solving, we add 1, and we get negative 8 equals negative y. To get y alone, we can divide by negative 1, and we get that our missing value of y is positive 8. Okay, same concept on this next one, but we're trying to find this missing x value, and we know our slope, or our m, is 2/5. So I'm going to label this x1, y1, x2, y2, and just like we did right over here, we're going to use that formula to fill in the pieces that we do know. We do know our m, we do know our slope. Our slope is 2/5. So 2/5 equals y2 minus y1, or 6 minus 2. I'm going to go ahead and just make that 4. Over x2 minus x1. So I'm going to have x minus negative 3, or x plus 3. Okay, and you might remember when we're solving equations where we have a fraction set equal to a fraction, we call that a proportion. So I'm going to go ahead and just cross multiply, and then we'll solve from there. So I have 2 times this, and then 5 times 4. So I have 2 times x plus 3 equals 5 times 4. Let's just solve from here. We get 2x plus 6 equals 20. Start isolating your variable. We get 2x equals 14. If we divide by 2, we get x equals 7. So that's how we can use our slope formula to find a missing value of our ordered pair.